I'm going to just jump into the next step. So the next step, what we see here is basically your sequences, right? So now we want to do sequences here. Um, so let's talk about what is a sequence. So you have this the long sequence of text in your document, right? It starts from first line in page 1 to the end of page, last page. So what is what is a sequence in this context, right? So sequence could be anything, but in this context, what the sequence means is it's basically breaking down of that one long sequence of text into smaller pieces. So that's what they call sequence in this context. So it could be one line in that entire document, or it could be one page, right? Say for example, if you have 500 pages, then it's 500 different sequences. And let's assume you have 10 lines per page, so if you so one line is considered as a sequence, then there is 5,000 sequences, right? 500 pages into 10 lines per page. So that's what sequence is called in this context. So how a sequence is arrived at is pretty straightforward. So it depends on how your input text is. Say for example, if you have a poem that you're trying to train, and the poems are usually 5 words per line, then it goes to the next line and then another 5 words, and that goes to the next line and another 5 words. So these lines are arranged in a certain format and it has some structure to it, right? So basically these lines have a structure to it, and this structure should be understandable for the machine learning. So when you take a poem, you probably take first one passage as one sequence, because that structure needs to be learned to the machine learning model. So you use that to understand the model better. So that is how you do it for a you create sequences. So in this case, since this is novel, so probably around take one sentences wherever you have full stop. So probably around 133 characters would probably make a good, or probably 130 would make a good sequence. So let's take an example and see how does it how does it look, right? So we come to the third step here. Out of the 6 steps that we wanted to look, the third step is creating a sequence. And then once you have the sequence, you create a corresponding target sequence for it, right? So all machine supervised learning should have a input and an output, right? So that's what it basically learns, the source and target. You need to map it. So in this case, we'll take an example and see what is actually the input sequence and what is output sequence, so that you understand how series prediction works, especially in your NLP languages. So in this case, if you see here, the first thing that you need to do is basically use TensorFlow library. I've imported TensorFlow library already as TF. So you use from tensor slices. You'd use that library. So it's pretty straightforward. It's pretty easy to use that and create a character data set. So basically, the entire sequence that you have, the numbered sequence, is basically converted into a data set now. So now if you want to create a sequence, so how do you create a sequence? So you use the dot batch of method that you have. So this is actually basically, if you see the data type. So let's take a look at the type of this this data set that we have created, that car data set. So if you see here, if I run here, so it will tell you, it's a tensor slice data set. This is actually the data type of this data set. So what we need to do here is the first thing that we need, that it has already done. What we need to understand here is, since we have passed in, you created the data set, right? Now you want to create sequences. So the first thing that we want to do is mention the sequence length, so which we've already assigned as 130 here. And since this variable is assigned, you are passing that as 130. So drop remainder is equal to true. It has some specific purpose here. The reason is, so once you are creating sequences of 130 characters each, it's not necessarily the entire the entire document is a multiple of 130. Right? Then there could be some reminder at the end. Probably the last sequence is probably only for 60 characters length or 50 characters length. You cannot use it because it's not the same shape as the other sequences. So you just drop that 50 characters at the end of the document, right? So that's what this specifically takes care. So internally that dot batch of function takes care of it. Takes care of that for us, right? So we use that method. And now if you take a few examples, right? So here what I've done is now take 5 examples, and so that we can see what it is about. And if you see this method, if you'll probably recognize it immediately. So this is actually that array, the numpy array that we created that helps to do reverse encoding, right? So now since we are passing that now in loop each item, basically this is a number, whatever highlighting, since you convert it, it's basically a number from the sequence, right? And it's since you pass it to the array, that array basically will return you the corresponding value for it, and you print it, right? And since you are taking running it as an iteration, so it's just going through each and every element in the sequence and printing it across. And at the end, what you notice is you'll probably see sequences here. So what I'm highlighting is the first sequence, and this is the second sequence. And if you manually go through it and count it, you'll probably notice that it has 131 elements in it. Right? So that's what this is basically doing. So it's created sequences. So I've taken some 5 sequences here and printed it out so that we can understand what's happening. So if you see, so we go ahead, now we are able to see the sequences here, or we could probably compare it with the text also to see if it's matching with that. So it starts with Project Gutenberg, The Adventures of Sherlock Holmes by Arthur Doyle. And that's what exactly we have. So you have that, and then it just continues here, but you just split it into a different 130 characters per sequence, so that you can use that for in the training more efficiently, right? So now that you have created sequences, you also need to map it to its corresponding target. So what is the corresponding target of each of these sequences? So what is it? What does it basically mean? So since we are predicting the next characters in the sequences, so obviously then the target would be the next character in the sequence, right? So let's take this sequence for example. This sequence ends with at no cost, but the n is split into the n is in the first sequence, but the o is moved on to the next sequence. So if logically, if you want to predict the next character in the sequence, your target should be O, right? So if you are trying to predict the next word in the sequence, your target is no, right? N in the input sequence and O in the output sequence. So that is how we map, create the target sequences here. So I'll show you an example how it is done, right? So I'm using that creating a method to split it. So first thing that I'm going to do is create the input text. So input text basically takes that sequence. The chunk is basically your sequence. Takes that one sequence at a time, and takes all the elements till the one element before, right? So not the last element. Select all the elements except the last in the list, right? So in this case, so it takes everything from here to here. So this is your input sequence, right? And your target sequence. So if you so what would be the logical target sequence here? So you start from here until here. That would be your target sequence, right? So this ensures that your both input sequence and the target sequence are of the equal length, right? And also it ensures that it has that next character as your output sequence, right? So that's what we are doing here. So your target text for the same sequence. So would be all the elements till the end except the first element. So that way you have the same length between both the sequences. So sequences, you have the sequences, and now I'm mapping that using the dot map method. I'm just gonna pass each one sequence at a time to this method, and so it gives me corresponding input text and the target text for each of the sequence. Okay, so in this we will be able to see better what we have tried here. So like I said, so you are, except that n from the first sequence, everything you have in the input data, and the target data basically adds that n to it. And this first return key, right, so that now /r character is removed from the target data, so that both of the input and target data are of the same length. So this is another example. You probably see, it ends with GU. The target sequence have one additional character to it, and that is your target sequence. So, and it's pretty much another way to learn how it works, right?